We go. Hello, everyone, and welcome to Cooking with Unity, episode 19, once again. And hopefully this time the whole thing will record. So, here we are, back in Unity land, and I actually haven't been doing this for a while, so hopefully this will be a good show tonight. So, in our last episode, we had a little ship, and he can... Well, I'm loading here. I should have done this... Oh, yeah. In our actual game level, we have a little ship and an asteroid. And the ship moves around, and you can shoot at the asteroid with the space bar, and that's about it. So, here we go. Wow, it's weird having a live audience. It actually does change the way that I'm thinking about things. It shouldn't, but it does. Alright, so first off, let's make it look a little bit more like asteroids and put a few more asteroids in here. So we've already got one asteroid. Let's move it a little further away from the player ship and duplicate it a couple times. Command D or Control if you are on Windows. And just put them in a few random places. Do that again. Alright. Alright, so we've got asteroids, they're moving around, and we can shoot them. Alright, cool. That looks more like asteroids. So, what I'm going to focus on this episode is AI. And it's kind of a weird game to do AI stuff, but it's also a game that the original Asteroids had little ships that would fly around and shoot at you. And so we're going to implement one of those in this game. So it's very, very basic AI, no pathfinding, nothing fancy. But it's a good little exercise and gives you an idea how to add a little bit of behavior and randomness to characters. So let's start by creating a ship for our bad guy. What did we go with last time? Let's try a capsule, and then we're going to... What are we going to do with this? Let's create an empty game object and throw the capsule in it. Oh yeah. Create empty game object is in the game object menu. You will not find it in this create menu for some reason. I don't really know why. I'm sure the Unity folks have a reason. So what were we going to call this? We're going to call this enemy ship. And we're going to throw our capsule in it. We're going to adjust the capsule to be, okay, so it's 000, perfect. And let's rotate this thing so that that didn't do much. Okay, that's the wrong one too. Trial and error for the win. Alright, so we have our capsule, and let's put a little ship thingy on top of it, like a little cockpit. So we're going to create a cube, throw that into our enemy ship, and we're going to move it, offset it a little bit here. Let's look at what we're working with here, and make it a bit smaller. And move it a little closer. Actually, let's make it a little wider too. Alright, so we got a little alien vessel of some kind. Let's actually make it a different color too. Let's make it red so it stands out. What are we looking at? We want a new material. Oh, there we go. And we're going to call this red, and just change the color, the diffuse color, to red, and that's all we should need. And we're just going to drag it into our enemy ship. Well, rather, into our capsule and our enemy ship. Alright, so we've got an enemy ship. So, what are we doing? First, I'm going to make sure this is on the Z plane that the player is. And let's start making some AI for it. So, first off, we're going to make the ship shoot at the player. So, let's open up... Actually, let's create a new script. C#. We're going to call it enemy ship. So let's first start by creating a couple of variables for our enemy ship. Let's go with, we're going to start with shooting, so let's do stuff that's just related to shooting. So we're going to need a game object that represents our bullets. And let's make a public float bullet speed. And actually, that's not the appropriate name for it. Let's do bullet force. And well, let's start with that. So in our update loop, oh wait, no, we want more here. We want public float, not fire rate, fire delay. Alright, in our update loop, what we're going to do is we're going to... Actually, no, we don't want to put this in our update loop. In our start function that I just deleted for no good reason, we're going to set up a invoke command, invoke repeating, rather, so that every so often we run our fire logic, our shooting logic. So I'm going to create a new function. We're going to call it void shoot. And in our start function, we're going to invoke repeating shoot in quotes and fire delay and fire delay. And actually, while we're in here, let's put some meaningful initial values here. I'm going to have the bullet force be 1000.0f. And I'm going to make the fire delay 1.0f. Oh, equals 1.0f. So what this will do is this is going to run this script every fire delay in seconds. And that's what it does. It just runs, this function. Call this function. So whatever we set for fire delay, this thing will use it for the initial shot and every shot thereafter, and it will call this at that rate. If we adjust fire delay in the editor while the game is running, we will not actually notice any difference because this is done once at the start where we set up our invoke call. We could change the script later so that you can adjust and tweak in real time, but it's not that big of a deal in a game this simple. So I'm going to delete the update function because we'll probably need it later, so I'll just leave that there. But so our shoot function, what we're going to be doing is shooting towards the player, and we're going to first shoot exactly right, and then we'll add variables later to make it so that there's some error in the shooting. So, where to start with this? Let's start with a... so we have... we're going to need to know where the player is. So let's add a reference to the player. No, let's not add a reference to the player. Let's actually do this by tag. So let's first make sure that the player is actually tagged as a player. It is not, so we're going to go over here and tag the player as player. And the reason I'm doing this by tag rather than by dragging in a reference to the player is in the event that we add multiple lives, or we maybe there's a power-up that has multiple players or something, and we want to have the script work in any case, in case this object gets deleted or we instantiate it at runtime later and then we wonder why our scripts don't work anymore. Doing it by tag is just it's a good way of getting things at runtime, and I'll show you how we do that. So first of all, we're going to get our player. So we're going to make a let's see, reference to the player right now. Game object player equals game object dot find with tag, and we're just going to hardcode player in here. We could also make that a variable, but this is pretty safe for this type of thing, especially considering the player tag is actually built in. You don't even have to set that one up. You just have to make sure that whatever it is marked with it. So find with tag player. So this will give us one object that has players. So if we had multiple players, it's just going to pick whatever's more convenient for Unity. And it will probably be the same thing every time. Like, it's not like it picks a random one or whichever one's closer or whatever. It's just whatever's in the list at the top is what you're going to get. So now we have our player, and we know where we are, and so we need to instantiate a bullet and then throw it in the direction of the player. So here we go. Let's do a instantiate command. We're going to instantiate our bullet. We're going to instantiate it at our transform dot position, and we're going to use quaternion identity here, which is just, it's basically zero rotation. It's just whatever the identity rotation of that object is. So now we're going to need to add a force to this object, so we're going to need to create a temporary variable for it. Game object bullet instance equals, and then we do an as game object. This is a fancy typecast, so that what this returns will actually return properly and be stored in this variable. Alright, so we have our bullet instance, and so we're going to apply a force to it. So bullet instance dot add, rigid body dot add force, and we're going to just add what do we want to do here? So let's first start by doing some vector math. Oh man, I did diagrams last time. I did all this overachieving last time I did this episode, and now I feel like I have to live up to it again. Alright, so let's pull up... Well, I'll show you the math first, and then I'll kind of explain it. So first we're going to want to figure out our vector for the direction that we're firing. We're going to be using this force parameter, so we don't actually care about how far away everything is. We just care about what direction it is. So I'm going to create a vector3 shot direction equals, and we're going to take our player position, player dot transform dot position, and we're going to subtract our ship position right here. So that's game object dot transform. Actually, we can just do transform dot position. So that's nice and short. And so this will give us a this gives us our vector And I'm gonna go ahead and pull up Pixelmator and actually do a little bit of the diagram again, even though they're terrible diagrams. I need to get a good workflow down for this. I don't know why I didn't think of actually checking into this after flailing around drawing before, but so here we go. So when you have a vector, it's basically an arrow that represents, in this case it represents positions, but it just represents direction and magnitude. It doesn't technically represent position unless you're using it as an offset from the origin, which we are. Not to make that any more confusing than it has to be. For some reason at school they always wanted to be sure that I understood the difference between points and vectors, when actually there's very little difference. They're both three components. They both describe things, and a vector can describe position just as easily as a point can. So I don't know. So here we go. So say we have a vector. This is our vector. It goes in some direction and it has a magnitude. And say we have another vector. If we add these two vectors together, it's basically just taking this vector and moving it. Oh, dang it. I need paint. I need some paint equivalent. Does this work? Yeah, there we go. So we'd put it at the end there, and that's the resulting vector is this. Deselect this right here. That's the resulting vector. And so we have two vectors. One describes the ship position from 0, and one describes the player position from 0. And if we add these two together, you get a resultant vector that looks like this, and that doesn't make a whole lot of sense, does it? Oh, yeah, that's adding. We're not adding them. We're subtracting them. So subtracting is a little bit different. If you have a vector and another vector, subtracting just straight up gives you this vector right away. It doesn't do anything other than that. So does that? Yeah, that makes sense. Because if we add it, it would go over here. Okay, got it. I've probably just confused everyone at that point. Did that make any sense? Anyone who's watching here? All right. So this represents basically the direction and magnitude to the player, because we take the player minus the current position of the ship. So it's the direction to the player from the ship. So we're going to normalize this. You can just put brackets around it and then do dot normalized rather. And so now shot direction has a unit component. So why that's important is it means that it's 1 unit in length, so we can multiply whatever value we want in, and we'll get that value in magnitude. And so that's what we want. We want our bullet force multiplied in on this normalized vector, and then we will get the results that we want. So let's go ahead and do that. We're going to add force, and it's going to be shot direction times bullet force, which is our scalar in this case. And that should be it. Let's see what this does so far, considering we haven't really run anything since we started programming this. So first I'm going to actually remember to attach this to the enemy ship this time. And we're going to hit play, and we're probably going to get shot to death real quick. Nope, we're not. Oh, we didn't actually set up a bullet. So enemy ship, we need to set a bullet. We're just going to use the same bullets that the player uses. So here we go, and it shot at me. Yay, it works right off the bat. Now, right now it's not leading target, so only if I'm staying completely still will it hit. That doesn't look right, does it? Looks like it's doing something wrong, doesn't it? That's interesting. That's not very far off, but it's not going right. Oh. Does this thing have a collider? Are there colliders on this thing? There are. Okay, so that's probably the problem. I think the bullets themselves are colliding with the ship. So let's fix that. And I'm going to do it different than I did last time. I'm going to do it with the layer system. So let's make the bullets be on. Oh well, they're the same bullets for both the player and the ship. So that's why I did it the other way last time. Alright, so what we're going to do is we're going to instantiate the bullets slightly in a radius around the ship. So what we will do is, what are we going to do? I'm going to make this shot direction, we're going to move it up a little bit in the script. And now that we have that, we can actually use that in this function here. So instead of transform position, we're going to actually do transform position plus shot direction. And I'm going to create a new variable here, public float bullet instantiation radius. It's a real mouthful. I'm going to make it 2.0 f to start with, and that should work. So, times bullet instantiation radius. So now what we're doing is let's do another little diagram. New. These horrible diagrams. So, we have our little ship dude. Not an artist. There, that looks like a pile of poop. And, we are now going to be adding a vector to its transform position. So transform position represents this point right here. We're going to be adding one in the direction of the player. So if the player's over here, that's a player, I guess. And so we have this vector to the player that we've normalized. So we're actually adding this to the position. So we're going to be spawning it hopefully outside of the collision radius of the ship. So let's give this a shot and see if it worked right off the bat. And see if it solves the problem of the bullets not really hitting in the right place. Oh yeah, I forgot about that problem. Well, yeah, it's definitely, you can tell it's more accurate, because I'm having trouble not getting hit. Let's see if it works from all angles. And you can see that it actually kind of appears in a radius around the ship, which we can probably get away with just fine. But it still is not leading the targets, and that's fine. We haven't programmed it to do that yet, so I'd be very surprised if it started leading the targets on its own, because that actually might be AI, as opposed to what we're doing. So we've got a ship. It's shooting at the player, and it's 23 minutes in. I think we're doing good. And hopefully, I'm not going too fast for anyone. So let's add a variance to the shot. Let's not worry about leading the targets just yet. Let's do a variance to the accuracy. So we're going to make a public float accuracy. We're going to make it equal to 1.0 f, and I'm going to have that be perfect accuracy. So what are we going to do here? First, I'm going to comment some of this. I need to get better about doing that anyway. Get our player by his tag. Its tag. Its tag. Determine the direction to shoot by. That's good enough for me. Instantiate the bullet. Throw it at the player. Alright, so where were we? We've instantiated the bullet. We've added a force. Okay, so we're going to add a randomness to this. So instead of just shot direction, we're going to also add a... let's see. Yeah, let's actually do this on a couple of lines. We could actually just stick it into that line, but I'm going to do it here so that you can kind of see what's going on. So we want modify, actually, vector 3 modified shot direction. And what we're going to do that is shot direction plus random dot inside unit circle times 1.0 f minus accuracy. And we probably need these in brackets because I want that to happen first. So what this does is we've got a shot direction. This gives us a random inside the unit circle, so it means that it will pick a some vector inside of a circle. That doesn't look like a circle, does it? Okay, I guess it's showing up on the video. And then we add that to our shot direction. And I think we're going to have to cast this as a vector 3, so I'm going to do that now. Vector 3. So, and then now instead of shot direction, we're going to use modified shot direction for the bullet instance here. So let's see if this works. So we're going to hit play, and actually I'm going to stop real quick and disable the collider on the player so that we don't go off the screen immediately. So turn off the box collider, and I think this has a collider on it as well, which that's great. I didn't find that one last time, so I was still getting pushed around a lot. So here we go. It's shooting at the center of our player, and now if we change the bullet speed, bullet spawn position, thrust. Huh. Did I not save or something? I did. Huh. Accuracy. That should be in there, right? Oh, this is the player ship. I'm an idiot. Alright, here we go. Alright, so we have an accuracy of 1. Let's lower that a little bit. Oh, okay, there we go. And we should see, yep, it's starting to be a little bit more wild in the firing. That one went real slow for some reason. Huh. Oh, it's because I'm actually affecting the unit vector. So let me actually renormalize that real quick. Going back into our enemy ship. And we did not normalize this, so let's do that. So now it shouldn't change the actual speed of the shots, it should just change the angle. So again, I didn't actually save this, so let's go enemy ship, change the accuracy. Alright, that's good. It's funny that actually its spawn position is still pointed directly at the player right now because of the way I set this up. So it actually kind of looks like his gun. Like if we had a little gun floating around him, you'd see it like tracking the player perfectly, but then the bullets would be coming out very badly. I kind of don't like how that looks. So I'm going to actually fix that real quick. It's amazing the kind of things that get me, but that's one of them. So the reason that we have this problem is we're doing modified shot position later, and or modified shot direction. So we're going to put it earlier, and we're going to be using it in the place of shot direction here, and that should fix that little problem. And actually, transform position plus modified shot direction times... Yeah, that's right. That should do it. So here we go, it's shooting at me. I click it again, just bring the accuracy down a bit, and yeah, that looks better. Now it actually looks like it's still coming from the center of the ship and he's just firing and missing. I like that better. I'm not sure if you could even really tell the difference, especially on this video. You may not have been able to see the difference, but if you're following along, maybe you would have. Basically, you'd see the bullets would always be coming from here, and as opposed to coming from the center of the ship, based on its accuracy. All right, so we have our ship, and it's firing, and everyone was happy. So let's actually give this ship some actual AI. Let's make him move around a little bit. So let's go back into the enemy ship. And let's see here. So we're going to use this update loop that we've been ignoring the whole time. And or maybe we won't. Maybe we won't. Let's see. Yeah, I don't think we actually will. But let's add some more variables for our ship here. So we're going to do a public float ship speed. We're going to default that to 1.0f. That's probably not fast enough, but we'll give it a shot. And let's make a what else? Public float ship speed. Public float minimum time before direction change. Let's at least call it min time before direction change, because that's a little bit less of a mouthful. And we'll set this to 1.0f. I'm going to have to figure out math again. And max time before direction change. And so what we're going to do first is, and actually let's do a public private vector 3 movement. Actually, let's do move direction. So at the start, let's create a random move direction. So we're going to do move direction equals random dot inside unit circle. There is no on unit circle. There's an on unit sphere, but not an on unit circle. I really don't understand that, but that's okay. We're going to use inside unit circle and just do a dot normalized right there. So that'll give us that's equivalent to on unit circle. And as a matter of fact, I'm sure that on unit sphere actually is just inside unit sphere normalized. Well, you know, maybe I'm not 100% sure on that. It wouldn't surprise me though. So we have a movement direction. Now we need to actually move it. So we will use this update. So our update loop is going to be very simple. It's going to be move direction. Actually, sorry, transform dot position plus equals move direction times ship speed. And that should be it. So if we start this right now, our little ship dude should pick a random direction, start moving in it. Oh, and I did the math wrong on that. You're going to see it move very quickly. Alright, so it totally did, but it's moving very quickly, and that's because I forgot to multiply in time.delta time. You'll be doing this a lot. What this means, again, is this is the amount of time that has elapsed since the last update. So assuming that it's running 60 frames per second, it represents 1/60th of a second. If you drop some frames or add some frames, it will always have the right amount of time in there, so it will move the object the appropriate amount that it would have moved if you had not dropped frames. So that's why you want it in there. It also makes the values make sense. So like this 1.0f now, because of the time.delta time here, means that the ship is moving at 1 unit per second. Without the time.delta time, it's 1 unit per frame, which is considerably more. So let's give this another shot. Still seemed fast. Oh, I didn't save. See this little yellow there? That means I didn't click this button. Let's try it one more time. Alright, it's moving. It's moving nice and slow. Excellent. And probably too slow. Let's pump that up a little bit. I'm just going to do it on the ship here. Actually, we can do it while it's playing, can't we? So we're going to make it move, and we're going to do movement. Let's try 3. Yeah, 3 seems pretty good. So I'm going to go ahead and unplay and hit 3 again, so it's actually saved to the scene. And speaking of saving to the scene, I'm going to save the project and the scene. Let's save the scene too. Save it all. Alright, so now that we're saved, and hopefully everything is still running video-wise. It looks like everything's going good. And what are we doing? It's good to be back doing this. I really enjoy doing this show, and I kind of had forgotten just because of how upset I was last time I lost this. And it's not too bad to redo this. At least 2 weeks later, it's not too bad. I tried to do it that night, and I just couldn't. It was just too hard to just do the same thing again. So we have the movement direction, and we have the ship moving. So now we want it so that it actually chooses a new direction every once in a while. And actually, let's make this 6.0. Probably should have done that earlier, but whatever. Actually, let's do 5. I like 5 better. So my goal is to make it so this min time before direction change is the minimum amount of time before it decides to make a new direction, and the maximum amount of time is the maximum amount of time. So it will pick some time in between those two values. So we're going to work through the math again on this one. Hopefully I'll remember some of it from last time, but it's pretty easy to figure out in your head anyway. Or not on your head, but trial and error, or just, well, kind of in your head. Well, you'll see. So what we want to do is, let's actually create a new function that determines our move direction. So void change direction. And what this is going to do is it's going to do just this. So I'm going to actually move this out of the start. And at the start, we're just going to call change direction. So now that we're changing direction, oh, we've got another viewer. Hello. Oh, no, we got, yeah. I was looking at the wrong numbers. Yeah. All right. So we've got change direction. It just picks a random vector, and we start moving in that direction. So what we're going to do is we're going to want to invoke change direction every so often too. So we're going to do an invoke, and I'm not doing an invoke repeating this time, and you'll see why. It's because if we did invoke repeating, we'd have a set time. Like, it would basically pick once, and then it will always change at that same time. And we want it to be random every time. So we're going to just do an invoke, and so this does it once after a time. So method name is change direction, and the time is going to be between our min and max time. So the way we're going to do that is random dot value times min time before direction change. So what this would do is between 0 and 1. That doesn't make any sense. What am I doing here? We want random dot value. I always choke up when math shows its ugly head, even though I actually really love math. All right, so random dot value times something. We want it to represent something. So let's we're going to do max time before direction change. I'll just paste that in. Minus min time before direction change. So if we do that, this will give us right now between 0 and 4. And then we add the min time back in. Let's try that. So plus min time before direction change. So, and we need to actually do the last thing there. All right. So we have a 1.0 here and a 5.0 here. So max time 5 minus min time, so that's 4. So this gives us a value between 0 and 4, and then we add 1 to it, which gives us a value between 1 and 5. All right, that sounds right. Magma Lemur points out that he would do a random range min time max time. The problem with that is you have to do you would have to do casting from an int to a float, and all of a sudden if you did 1.5 or 5.7, those wouldn't mean anything at that point. So you lose some precision on that. But yes, it's an easy way to set it up. But it handles floats fine, really? Hold on. Random dot range. Int minute. Oh. Wow, I'm retarded. Yeah, let's do that. That's much better. Thank you. Thank you, Magma Lemur. Almost said your name on TV, oh no. Alright, so let's change that. I feel really dumb. Random.range, min time before direction change, and max time before direction change. Yeah, that's simpler. So, yeah, alright. And what we're going to do is... actually, let's not even put this invoke in here. We don't even need this in here. We're going to put it inside of change direction, because we're calling change direction directly here. And so it's going to choose a random direction, and then it's going to invoke itself after that time. So let's see if this does what we were expecting. No, I don't feel dumb. I just find it funny that I didn't run into that sooner than now. I was just like, random.range, that's great for like picking something out of a list, but yeah, no, there's a float version, and I didn't realize it. So hit play, and we got the ship, and it's moving around, acting kind of. Oh, it's moving pretty well. Wait, 1001, 1002, 1001. Okay, let's start counting it again. Oh, I know what happened. It's probably because I changed this variable layer. Yeah, so it's every second right now. If we do 1 and 5, it should be a little bit more random. So 1, 2, 3. Okay, 1, 2, 3. 1, 2, 3, 4, 5. 1, 2. Yeah, looks like it's behaving a little bit more randomly now. So yeah, it moves around and fires at the player, and we basically have a very, very dirt simple AI. I think there's a name for this type. It's a random walk. It might even be. This might even be a simple implementation of Brownian motion at this point, for all I know. But yeah, it's just a very simple, just random walk based. So you just choose a direction, it walks in that direction, and then you choose another direction after a time. And it makes for an enemy that actually has, this is not intelligence. Like, no games have real intelligence. Although we could make it so that they dog the player a little bit more, and I might actually change that in a bit. But yeah, so let's clean up what we've got so far and make it so that the player can die, and make it so that we can kill the enemy ship, and then we'll see where we're going from there. I like that the bullets bounce off the enemy ship. Just like, I'm invincible! Alright. So we have our enemy ship, and we'll probably make a little spawn script or something so that these guys will spawn off the screens. So first, let's make it so the enemy ship will die when it gets hit. So what do the asteroids have on it? We've got, is that just built into the asteroid script that we make them blow up? On collision enter, yep, that's in our asteroid script. So let's create a real quick one. We're just going to create a very short script. Destroy on collision. Yeah, that's good enough. If it runs into an asteroid, that's its own dang problem. As a matter of fact, that's what we'll do. We'll have the ship try to perform collision avoidance with the asteroids later, and that'll feel a little bit more like an AI. So, destroy on collision. Dirt simple script. We're just going to delete all this. Void on collision enter. Destroy game object. As I said, dirt simple. And so we're just going to throw this on our little enemy ship. Oh, and this is not going to actually work. Like, if I do this, we're going to see that it's not going to work. I actually ran into this problem last time. Yep, still invincible. No, you must die, but I'm invincible too. I have a phase shifting mechanism, and that thing just has a hull that's impenetrable. Or something. I'm just making up things. Remember back in the day when you were a little kid and you'd play video games and you didn't know that there were bugs in video games? You would just run into bugs and just have to make up reasons for them to... I guess maybe I was the only person that did that, but I know that me and a few friends would always just like try to make up excuses. Kind of the old case of a wizard did it or something. Yeah, it does... Oh yeah, thank you for telling me to remind me to clean up the bullets. And it is browning emotion? Good. Alright. So what am I doing? Lost my train of thought. This is actually the first time I've had an audience that's been active, so this is kind of exciting for me. So first of all, the reason that the ship didn't get destroyed is because the collision events are actually being handled by the capsule and the box collider that are on the children. So we're going to create a new version of destroy on collision. I'm just going to duplicate it, Command D, and we're going to change it to destroy parent on collision, and we're going to edit it very slightly. And so instead of just game object, we want game object dot parent. No, sorry. We want transform dot parent dot game object. So this is the attached object, like the object that the script is attached to. It's transform. The parent that's in that transform, and then the game object that represents that transform. Like this is the parent is a transform, so we need the game object from that. So this should actually work if we attach it to the children. Can't okay. Oh, didn't finish compiling. Oh, there's a. Oh, yeah, because I duplicated it. Clicked the wrong thing. So destroy parent on collision needs to actually be called destroy parent on collision. And so now we can attach this to our cube and our capsule. Did I attach the right thing there, or did I drag the wrong thing in there? Destroy parent on collision, destroy parent on collision, and I'm just going to get rid of this destroy on collision because it doesn't do anything. So let's see if this works. If we hit this thing, if it dies now. Yep, totally died. Cool. Gonna have to add some of my signature block gibs at some point, but that's fine for right now. It actually died. So we have that working. Let's do the same thing with the player ship. We're going to put a destroy on collision for the player ship, and we're going to destroy parent on collision for the cockpit. So the player ship we've set up a little bit differently. It's instead of being an empty game object that has children for its both geometry, it's a cube that has a child for another part of it, but same concept. So that's the reason we use two different scripts on that one. So now if it shoots at us, oh yeah, we still have the collider turned off, and we're totally going to get creamed by this thing. I may have to make it shoot a little bit slower. No, don't get me. Oh yeah, it crashed into an asteroid, and I'm going to too, just test my collision. Yeah, it works. Alright. So alright, clean up the bullets. Let's do that. So let's do the alright, we're not going to do the standard off-screen cleanup like I would usually do, because I actually do intend on showing you guys how to make this screen wrap, which I think will be fun because I've never actually done it before. Not in Unity, at least. So we're going to actually make the bullets do what they do in Asteroids, which is they have a lifetime. So our bullet, let's create a new script. Our bullet currently has no scripts. It is literally this dumbfire projectile. We just throw a force on it and it hits things, which is wonderful. But we're going to make it have a very small script. Destroy after time. And thank you, Dark Rowan, for the suggestion. So, destroy after time. What we're going to do is... Actually, I guess we just need a start for this. We're just going to invoke method name. Alright, so we're going to create a little function called void destroy self. Actually, let's call it self-destruct because it sounds cooler. And my tabs aren't working right now because I just left this function invoke hanging here. So invoke self-destruct, and we need a variable. I'm kind of doing this entirely out of order, but that's okay. Public float time. Let's not call it time. Let's call it time. Lifetime. Let's go with that. Lifetime sounds good. I don't know why I spend so much time just on naming things, and I have very little consistency in my variable names so far. At least I do usually use camel case, although now I have to question whether lifetime is one word or two. Lifetime. Alright, lifetime. And self-destruct is just destroy game object. And so we'll default this to 1.0f so that it actually has a meaningful default. And now when we hit play, both our projectiles and the enemy projectiles should have Oh, yeah. No, they don't do anything yet because we didn't actually attach it to our bullet. So destroy after time, bullet. Off-screen destroy. Actually, easiest way here. Actually, I'm going to do it real quick just because it's super simple. Destroy on invisible. I actually, let's do destroy when off-screen. I was giving away the secret before I even said it. So, there's a callback, a function that gets called. You know how you have these built-in functions, start, update, and then there's other ones that are kind of hidden, like on collision enter. There's actually one called void on became invisible, and this function just gets called when an object is no longer viewed by any camera. And so this is the easiest way to destroy something when it's gone off screen. So all you do is just type in destroy game object like normal. And let's see if this works real quick. We've done this in a previous episode, so I'm going to attach this to the bullet. I'm going to temporarily remove the destroy after time script, or at least disable it. So we should see, when I fire, you see the bullet clones are actually going off the list as they go off the screen. Oh, and we are getting an null reference exception because we don't have a player, so we need to handle that at some point, but I'll fix that next episode. Yeah, that's really nice, isn't it? Really useful. So, sorry about that tangent. I'm going to get rid of the destroy when off screen, and we're going to turn on the destroy after time again. And, alright, I feel like there's a point for me having a live show now. It's really nice to have an audience. So I got shot real quick there, so let's see if this is actually working. Oh yeah, you saw it. He shot and it totally did something. Let's make it so that the let's do something fun here. I said I was going to fix it next episode. I want to do it right now because I like doing things. So enemy ship. What are we doing? Player find object with tag. So if player equals null, we're gonna have it shoot at asteroids at this point. Why am I using a variable called player? Let's try target. And where else am I using player? Player. Alright, so target. That's the only other place, right? Okay. And we're gonna have it just shoot at random asteroids once it does this. Game object target equals game object dot find. How does this one work? Name. Let's do find with tag again, and we're gonna do asteroid. Just real quickly doing this one to end this episode up. And we didn't need to do this, but it'll be more fun. And we don't need to redeclare target. And then let's just do one more here, just to get rid of our null reference exception. If target equals null at this point, we just won't do any of this. So if it does not equal null, we'll do all of this. That's what I meant to say. If target does not equal null, do that. Otherwise, do nothing. Alright, so now this thing should shoot at asteroids, assuming we tag our asteroids. So I'm just going to go large asteroid, and I'm going to add a tag. I'm going to user layer 8. Wait, no. Tag, sorry. Those are layers. Asteroid. I said asteroid, right? Yep. and then we go in here, and we actually set our asteroid to asteroid. So now if we hit play, it'll shoot at the player, kill the player rapidly, and then it will start targeting asteroids. Yeah, that's awesome. It will continue to shoot at one of the asteroids, and it does not appear to care about the range. So, and it doesn't try to shoot the nearest one right now. But at the very least, it's making pot shots at asteroids. So, it's 9 o'clock. I'm going to call that an episode, and I'm very happy that it recorded and everything went well. So, thank you guys for tuning in tonight. Glad that we're back on track with the show. And thank you guys literally for tuning in. Thanks for actually watching the show live. And if you aren't watching the show live now, which is to say later, hope you enjoyed the show. And remember, if you want to email me at pushypixels@pushypixels.com. I love feedback. If you have questions about Unity, I love to talk. And if what else? Oh yeah, I'm gonna plug my product again. Proton Pulse. Buy Proton Pulse, please. It helps. It helps me. It helps me eat. And thank you very much. And you guys have a great